Concerned viewers, welcome to this week's edition of Planet Earth, Our Loving Home, featuring our program on the state of Arctic sea ice and glaciers. The Arctic is the polar crown of our planet, yet the ice and snow in this precious area are disappearing at an unprecedented rate due to climate change, which is driven by the production and consumption of animal products. These destructive practices are the main source for the human-generated greenhouse gases rapidly heating the globe. Today we'll examine how the beautiful but fragile northern polar region is vital to life on our Earth and how it affects weather and climate. One way in which the Arctic plays a key role in regulating global temperatures is through the ice albedo effect, by which the area's ancient layer of snow and sea ice reflects 85 to 90% of the sun's energy back into space, keeping our planet cool. Hence, the more ice and snow that are present in the region, the cooler our Earth becomes. However, when this cover disappears, the opposite effect occurs, as the dark Arctic Ocean and exposed Arctic land absorb the sun's energy and cause planetary warming, which in turn drives more melting and more exposure of these non-reflective surfaces. Oceanographer Dr. James Overland of the U.S. National Oceanic and Atmospheric Administration's Pacific Marine Environmental Laboratory directs research on this phenomenon and will now provide more details.
With ice there to reflect the summer sunlight from the white ice, we absorb a whole lot more heat from the sun that the Earth normally used to not get, and that heat is returned to the atmosphere in the fall, and that helps set up these highly variable climate patterns. A lot of people know that the Arctic is warming twice as fast as anywhere else on the planet, but what we're seeing now is new evidence that this is really accelerating. In 2007, we were really surprised that we lost about 40% of the area of the ice that's normally covered during the summer, where it looks like this process will continue. It'll go up and down. We'll have more or less ice, but we're on a downward trajectory caused by global warming.
The planet is warming, and we're seeing an amplification of that warming in the poles of the planet, particularly the Arctic, so the northern pole. We're just coming into the summer conditions in 2010, so we've been watching the aerial extent of ice quite closely, and we're finding that the ice conditions look to be quite light this year, and that we're probably going to lose quite a bit of ice through the summer, and so we're expecting it to be another year that's fairly similar to 2007, which was the last record of the minimum extent of sea ice in the northern hemisphere.
For millennia in the Arctic, new ice formed annually over the remaining ice from previous years. However, nowadays the ice is so thin in many places that this multi-year ice has nearly disappeared. Professor David Barber, Canada Research Chair in Arctic System Science at the University of Manitoba, Canada, explains the situation.
What happens in the Arctic is that when we lose the ice, we're really losing multi-year sea ice, and that is being replaced with first-year sea ice. So multi-year sea ice is the stuff that survives a summer and starts to regrow again the next year. So it can become quite thick and quite hard. And it used to be that 80 to 85% of the Arctic basin was covered with that kind of ice. We're now down to about 18% of the Arctic basin being covered by that kind of ice. And what happens is, as we lose that ice, it's replaced in the fall with this first-year ice, which is much thinner. It has a maximum thickness of about 2 meters. It's much more saline and much warmer, so it's much easier to break, and it's much more susceptible to winds and wave action.
The frightening loss of Arctic sea ice and glaciers has other profound effects on global climate. The delicately balanced ocean current circulation system has many functions, such as carrying vast amounts of energy from the cooler to the warmer parts of our Earth and providing moisture for northwestern Europe's precipitation. This highly complex thermohaline circulation system is driven by differing temperatures and densities of seawater, and any destabilization of this process can have planet-wide climatic effects.
If you put in additional fresh water into the North Atlantic by melting Greenland or by having more discharge from Siberian rivers, then you can freshen the North Atlantic so strongly that there won't be any sinking of water anymore, and that would disrupt this thermohaline circulation and could make it stop. Because there's so much heat transport associated with this thermohaline circulation, it's going to disturb the entire climate system.
Professor Anders Lieberman and other scientists say that disrupting the thermohaline circulation pattern could cause a 10 degrees Celsius drop in average temperature for Europe, effectively destroying agricultural production on the continent, shift rainfall away from environmentally sensitive areas such as the Amazon rainforest, or even result in a 1-meter rise in the North Atlantic Ocean. We'll now pause for a brief message, and when we return, we'll examine other ways in which Arctic warming can severely affect global weather and climate. Please stay tuned to Supreme Master Television. Welcome back to today's Planet Earth, Our Loving Home, where we are focusing on the state of the Arctic, which is rapidly warming due largely to the production and consumption of animal products. Use of the term global warming sometimes misleads people into thinking that rising temperatures are the key indicators of climate change. But in fact, planetary heating also leads to a variety of extreme weather events, such as severe snowstorms and unusually frigid temperatures. For example, the winter of 2009-2010 saw drastically cold, snowy weather in several parts of the globe, such as Mongolia, Europe, China, and North America. For more insight on this topic, Professor David Barber will now explain the difference between weather and climate.
The reason we call it climate change is we're interested in the average change. So a good way to think about it is that climate is what you expect to see if you look out your window. So if you wake up one day and it's July, you expect to look out the window and see a sunny day and it's fairly warm and the birds are singing. That's the climate. That's what you expect to see. If you wake up and you look out and it's snowing in July, that's weather. It means that a freak weather storm has come in and has done something different than what you expect to find. And the similar can be said in the wintertime. If you look out in December, you expect it to be cold and snowy. But if you look out, that would be climate. If it's cold and snowy, that's what you expect to see. But if you look out and you see it's a nice warm day and all the snow is melted, that's weather. So weather is short-term things, climate are long-term things.
How is Arctic sea ice and glacier melting linked to the intense wintry weather being experienced in some regions of our Earth? Dr. James Overland now explains.
Actually, the Arctic is warming, and the heat that's stored from the summer in the ocean is given back to the atmosphere in the fall, and it forms a dome of high pressure and warm temperatures over the Arctic. But when it does that, it sets up some lower pressures further south, and it's the difference between these high pressure and low pressure that cause winds. So now we have more winds from the Arctic, from the north, and from the east that are occurring in mid-latitude Scandinavia, eastern U.S., and eastern Eurasia, and they're stopping the storm patterns that normally occur there. So we end up having the colder and snowier weather that occurred last December and last January are linked to the large changes that we're seeing in the Arctic now. So with the warming, you have more winds coming out of the north, but they're bringing relatively colder air from the north into the south. So that's why you have the cold temperatures. And it also is blocking a lot of the normal warm storms that occur further south and come into Europe. Normally it's the warm air temperatures coming from the Atlantic Ocean. These extra winds that are connected to the Arctic are blocking some of those warm storms.
While speaking at the recent International Polar Year Oslo Science Conference, Dr. Overland stated that for Europe, East Asia, and Eastern North America, cold and snowy winters will be the rule rather than the exception. Another highly dangerous trend occurring in the northern polar region is the release of stored greenhouse gases. As the Arctic warms, the permafrost or permanently frozen soil lying beneath the surface releases huge amounts of the toxic greenhouse gases into the atmosphere, leading to higher global temperatures, which in turn causes further release of gases in an endless cycle.
One of the things that we've realized is that there are feedbacks that begin to come into play and amplify the direct effect of human-made emissions. One of those is the release of methane as permafrost melts and from the continental shelf under the ocean. That comes about because of the warming. As the planet gets warmer, the ice melts and it releases this frozen methane. So that is potentially very dangerous. The way that we can avoid that is by reducing the warming, or by stopping the warming.
The effects discussed today will continue to increase and intensify unless global warming is quickly halted. And if the passing of certain tipping points occurs, runaway climate change will result in severe planetary instability. While the alarming state of the Arctic has already cost many lives and seems to portend a bleak future, a brief period remains in which we can save our planet's ice anchor and restore our Earth to a climate that can support life as we know it. The fastest and most effective way to address climate change is for the world to quickly adopt the organic vegan diet. This occurrence would mean livestock raising, an enormous source of poisonous greenhouse gases such as methane and nitrous oxide, would end. Our planet would then cool, with the splendid ice sheets and glaciers reforming, and our climate and weather returning to a harmonious balance. Finally, we would like to thank scientists across the globe whose invaluable research on climate change and the Arctic is bringing greater awareness to the public of the tremendous challenges facing our world. For more details on the scientists featured in today's program, please visit the following respective websites: Dr. David Barber, www.umanitoba.ca; Dr. James Hansen, www.giss.nasa.gov; Professor Anders Lieberman, www.pik-potsdam.de; Dr. James Overland, www.pmel.noaa.gov. Thank you, intelligent viewers, for your company today on Planet Earth, our loving home. Up next is enlightening entertainment after noteworthy news. May the Providence always guide us throughout our lives.
For more details, please visit www.suprememastertv.com/PE.